This is an instructional video detailing the applications and functions of the Phase II PHT 6000 series ultrasonic portable hardness tester. The PHT 6000 is designed to test metals, primarily steels, aluminum alloys, and copper alloys. But other metals can also be calibrated and tested using known calibrated standards of that metal. Because Young's modulus is the determining factor in this technology, these open architecture testers calibrate to material type and can be read in virtually any hardness scale. The technology incorporated is based on ultrasonic contact impedance. UCI utilizes a 136-degree diamond at the end of a vibrating rod being depressed into the test surface at a fixed load. At this point, the frequency of that vibration has changed. The difference in ultrasonic vibration frequency is then calculated into a hardness value. The UCI method of hardness testing is portable, easy, and accurate. It is slower than the dynamic Lieb test, but it also has certain advantages as well. UCI allows for parts down to 80 thousandths thick to be tested, while the dynamic systems could not handle anything less than the mass of 1 inch thick of steel. Maybe the most popular aspect of the UCI hardness tester is that it is classified as non-destructive. It can test hardened parts without leaving a visible indentation mark. This allows for less scrap parts and lower part costs overall. This scenario is perfect for sensitive manufactured parts, engine parts for automotive and aircraft, bearings, and many other surfaces that need to be protected. Note the Phase II PHT 6000 series is foremost a UCI portable hardness tester. However, it also has the ability to accept an optional dynamic Lieb probe and for large parts, easily take tests using the Lieb system accurately and easily. There are 5 types of standard manual ultrasonic probes. They are generally determined by the load to be applied for activation. They include 1 kilogram, 2 kilogram, 5 and 10 kilogram. There is also a long nose 1 and 2 kilogram manual probe to get into tight places. The correct load to be applied will be determined by the surface roughness of the metal to be tested. Motorized probes are also available for very thin work such as platings and coatings. Included in the kit carry case is the module, operation manual, and software on a USB stick, quick setup guide, probe cable, a power cable, and NIST calibrated test block. Let's move to the different functions and operations of the tester. Attach the 90-degree end of the cable to the probe, then attach the other end to the tester module. Power the unit on from the left side of the body. The interface will show you at top left the method of test being used, either UCI or Lieb. A timestamp is at the top, and to the far right is the battery indicator level. Just below is the probe type, then test times for average, then group number, your calibration scale setting, and material. The international standard being used for reference, the actual hardness reading with scale on the right. Just below is the conversion showing if selected. And below that are basic statistics, average, maximum, and minimum. The interface will power off after a short time without using the tester. Each tester is provided with 4 standard calibrations for different materials: steel to read in HRC, steel to read in Brinell, steel to read in HRB, aluminum to read in HRB. If desired, any other material scale combinations can be added with a known standard for calibration on the fly. They can also be individually named. The menu button on the keypad brings you to a selection of parameter settings: test setup, system setup, memory setup, data output, calibration, and probe selection. We highly recommend that you contact technical support to handle any calibration issues or to add calibrations of new material scale combinations. To take a test, Hold probe in a tight fist. Press the probe straight down flat on the surface of your part and hold very steady until the unit beeps and gives the hardness value on the display. Immediately lift the probe off the surface, then ready to take the next test. Proper use of the probe will help you to achieve correct, repeatable results. Continue testing for average. This procedure may take a few minutes of practice, but should come to you easily after taking tests on the supplied calibration block. The motorized probe will give you the most repeatable results since it eliminates the need to apply proper force. Place the probe flat on the surface of your part. The bottom of the probe is magnetized to help stay put on flat surfaces. Press the red button on top of the probe to start the test. Wait for the test result on the display before lifting it up and taking another test. For large parts, especially large cast, using the optional lead probe is quite simple. Plugging in the lead probe, then powering on, you should see the interface show the change to lead from method, and also the probe type to D or other type of probe that you're using. Taking tests is quick and easy. Spring load the probe and release from the top. The hardness reading will show on the screen. If using a lead probe, don't forget to purchase an optional HLD calibration block for verification of accuracy. This concludes our application and function guide for the Phase II PHT 6000 series ultrasonic portable hardness tester. Should you have any questions, please don't hesitate to contact us.